Hello everyone and welcome back. So in this notebook and series of videos, I'm going to be showing you a more powerful way to build neural networks in PyTorch. So in the last notebook, you saw how you can calculate the output for a network using tensors and matrix multiplication. But PyTorch has this nice module in that has a lot of classes and methods and functions that allow us to build large neural networks in a very efficient way. So to show you how this works, we're going to be using a data set called MNIST. So what MNIST is, it's a whole bunch of grayscale handwritten digits, right? So 0, 1, 2, 3, 4, and so on, through 9. And each of these images is 28 by 28 pixels. And the goal is to actually identify what the number is in these images. So what the data set consists of is it consists of each of these images, and it's labeled with the digit that is in that image, right? So ones are labeled 1, and twos are labeled 2, and so on. So what we can do is we can actually show our network an image and the correct label, and then it learns how to actually determine what the number in the image is. This data set is available through the Torch Vision package, and so this is a package that sits kind of alongside PyTorch that provides a lot of nice utilities like data sets and models for doing computer vision problems. So here we can run this cell to download and load the MNIST data set. What it does is it gives us back an object which I'm calling train loader. So with this generator, we can turn it into an iterator with iter, and then this will allow us to start getting data out of it, or we can actually just use this in a loop, in a for loop. And so we can get our images and labels out of this generator with, for image, comma label and train loader. One thing to notice is that when I created the train loader, I set the batch size to 64. So what that means, and every time we get, a set of images and labels out, we're actually getting 64 images out from our data loader. So then if you look at the shape and the size of these images, we'll see that they are 64 by 1 by 28 by 28. So 64 images, and then one color channel, so it's grayscale, and then it's 28 by 28 pixels is the shape of these images. And so we can see that here. And then our labels have a shape of 64. So it's just a vector that's 64 elements with a label for each of our images. And we can see what one of these images looks like. So this is a nice number 4. So what I'm going to have you do here is build a multi-layer neural network using the methods that we saw before. And by that, I mean you're going to initialize some weight matrices and some bias vectors and use those to calculate the output of this multi-layer network. And specifically, we want to build this network with 784 input units, 256 hidden units, and 10 output units. So 10 output units, one for each of our classes. So the 784 input units, this comes from the fact that with this type of network, it's called a fully connected network or a dense network. And we want to think of our inputs as just, one vector, right? So our images are actually this 28 by 28 image, but we want to put a vector into our network. And so what we need to do is actually convert this 28 by 28 image into a vector. And so 784 is 28 times 28. So when we actually take this 28 by 28 image and flatten it into a vector, then it's going to be 784 elements long. So then what we need to do is take each of our batches, which is 64 by 1 by 28 by 28, and then convert it into a shape that is to another tensor with shape 64 by 784. And this is going to be the tensor that's the input to our network. Okay, so go ahead and give this a shot. So again, you're going to build a network, 784 input units, 256 hidden units, and 10 output units. And you're going to be generating your own random initial weight and bias matrices. Cheers.